All right. And we're going to go to Matt, and we are going to make you the host. Change host. Okay, you are now the host. We are now recording, and I am going to sit back and listen. So hold on, mute my audio.
Well, we're gonna wait for people, right?
Yeah, I'll just bring in the slide up. You can see my screen?
Yeah. Yep.
Okay. Thanks for looking at this, Judy.
Oh, I'm impressed. It's great. It's working great, huh?
Yeah, yeah.
Oh, where's Laureen again? Hi, Laureen.
Hey, Judy.
We're waiting to see who comes.
All right.
We start at 7:45. How are you?
I'm good. Let me start my video. There we go. I think. Yeah. Ooh.
Hi. Okay, so
Hello.
Laureen is a good friend of mine, Matt, Ken, and Dee. We're doing these because we can't do them at the library,
Right.
and we're hoping, like 15 people sign up. It's like children's rec, 15 people sign up and how many people show up. So
Yeah.
there we back in the day.
Yeah.
So but they record it, and it's recording now, and we will have it on people could see it through the week or at the end of the week. So Laureen Leonard is, our girls went to school together. They've been together, knew each other since preschool age.
Yep. That's right. Look at him now.
Oh man. You might be our captive audience to start.
All right, well, I have 7:45, so we could get started. Sound good?
Sound good.
Okay. All right, so this is our library education series for the Parsippany Green Team. So welcome, everybody. This is the second of a series of weekly education series that we're looking at. And this specific topic is on geothermal ground source heat pumps. Last week, we did renewable energy aggregation, and that video can be found through the library. So if you want to see that content, it's going to be showing up every month. We'll be doing a presentation just on renewable energy aggregation. and then doing additional contents throughout there. But this one is specifically a new source of energy, geothermal ground source heat pumps. So this is sponsored by the Parsippany Green Team, Parsippany Library, obviously as the host, and this is a Sustainable Jersey program. And Sustainable Jersey is a nonprofit organization in New Jersey that promotes and facilitates resources, funding, and training for municipalities to pursue sustainable actions in our community. And the mission of the Green Team, which is the formation of the Green Team, is to collaborate with our residents, town government, and businesses community to identify and implement programs that improve our quality of life and the physical, environmental, and financial sustainability of our community. So at a very high level, I just want to back up and share the Parsippany Green Team goals. This year, the Sustainable Jersey program is built around a point system. There's about 150 actions in the program or more, and you get points for qualifying and doing certain actions. And this year, 2021, we're after this bronze certification, which is 150 points. Next year, we're after silver in 2022, and then we're going after gold in 2023. So the Green Team is pursuing actions across all of these 18 categories. And the ground source heat pump action falls into this energy category number 7. And we'll get into that right now. But as you can see, Sustainable Jersey covers a broad list of sustainable requirements for a town, from food to water to energy to waste to green design, brownfields, animals, innovative projects. So we're looking for as many people to get involved that have skills, resources, or even just a little bit of bandwidth to add to the team so that we can get more done in the town. With that being said, also wanted to highlight this library education series. As you see, we had an education series on January 12th on renewable energy aggregation. This is the ground source heat pumps. Next week is going to be on solar photovoltaic energy, followed by electric vehicles on February 2nd. And then we're going to be adding content weekly to buffer that again, and circling back on the renewable energy aggregation once a month. But basically, it's a Zoom virtual series. You can go to the library and sign up on the main library calendar. And we want to thank Jean and the library for facilitating and supporting us through this program. So jumping right into the content here, if you haven't heard of what a ground source heat pump is, I'll explain what it is. Essentially, this is a heat pump that acts as a central heating or cooling unit, basically transferring heat to and from the ground, and essentially uses a vapor compression refrigeration cycle. Sometimes that goes in reverse and sometimes it goes forward, depending upon whether you're heating or cooling. Can you see my entire slide here, or is it blocked?
I see it.
I can see it.
Okay. So this is also known as geo-exchange, earth-coupled heating system, or earth energy system. And this isn't necessarily to be confused with pure geothermal, which is digging way down or accessing steam or hot rock to create a power generation station. This is used for residential and commercial applications. And I'm going to get into the various kinds, but basically a ground source heat pump pulls heat out of the ground in the wintertime for heating, and then it transfers the heat back into the ground in the summer for cooling. So it's going to take the heat out of your house and then put it down into the ground where it's a lot cooler and it can take the heat. And the way that this works is that the ground temperature for pretty much the first 20 top feet of the Earth's surface are pretty steady temperature. And this is because the sun and the radiative effects of the sun keep that temperature pretty steady throughout the year. So once you get down below about 5 feet, you're getting in the 55 degree to 65 degree temperature zone pretty much across the continental United States. So it's very uniform, and it stays pretty steady, assuming that the sun can always warm pretty much the same throughout the process. But the schematic here, you're either extracting heat for the winter or you're cooling and putting heat back down into the ground and taking it out of your house for the summertime. And there's a tremendous amount of benefits to doing this as opposed to using fossil fuels, natural gas, or oil to heat your home. And obviously, one of the bigger benefits is that the ground source heat pump is recognized by the Environmental Protection Agency as the most energy efficient, environmentally clean, and cost effective space conditioning systems available. And you'll see the notations and the highlights. I have a whole reference deck at the end, which you can look at. But the EPA and the Department of Energy have recognized this technology as the best technology for heating and cooling spaces. And one of the reasons why it does that is because it has a 500% COP, or coefficient of performance. And what that means is that for every 1 unit of electric energy, it can transfer 5 units of thermal heat to or from the ground. And a natural gas furnace, or something that uses a fuel like oil or natural gas, can maximum efficiency is 100%. So already you're getting 5 times more efficiency out of a ground source heat pump. And that coefficient of performance will change a little bit seasonally, but basically you're not burning a fuel, so your theoretical limit is really about how efficient the equipment can be, and the pumps and the associated hardware. But number one benefit, you're using a tremendous amount of less energy to heat and cool your house. You can get free or reduced hot water. Likewise, for heating and cooling your house, you can also heat up hot water for your house. In my house, you can get the temperature up to about 120 degrees, which is plenty for hot water in your house for your showers or your sinks. And that is already built into the unit or can be added on, so you don't need to use natural gas or some other fuel to heat water for your house as well. It's very quiet and very flexible and offers low humidity options for your heating. So one of the things that's really good about ground source heat pumps, and I'll just speak for the heating portion, is that because it heats the water temperature or the air temperature to a lesser heat than traditional heat pumps in a furnace, it's more of a steady flux of heat in your house, so that the exterior walls of your house warm up, and the radiant heat off of the walls makes you more comfortable, even though the temperature is the same inside as it is as it normally would be, because your walls and everything else is warmer. So right now I have a ground source heat pump installed in my house. Obviously it's very comfortable in the winter time, and I'm going to get into some of those details a little bit more. And I mentioned quieter here because essentially in like an air conditioning system, you have an outside condenser unit that's very noisy when it turns off and on, that big fan that basically turns off and on outside. Well, that completely goes away, and you don't have any of that noise pollution in the outside of your house as well. And then because there's so much design flexibility with the ground source heat pump, you can install multiple components. You can install a heating system or just a cooling system or both. You can add on the hot water heater. You can do vertical drilling. You can do horizontal drilling. You can do any number of configurations to access the heat in the ground. And because of that, it has a lot of flexibility to any homeowner or any commercial building to satisfy the heating demand need for and cooling demand need for that building. And it's aesthetically pleasing. At my house, you don't see anything on the outside. And what the side benefit of that is that it reduces vandalism, because there's no exposure of equipment to the elements, including storms and weather-related events that could damage equipment outside. So it's makes for a very resilient system that, especially with climate change and increasing storms and activities, basically you can insulate yourself a little bit from some of the damages. It's about 1/3 of the maintenance cost of a typical furnace or air conditioning system. Many fewer moving parts and easier to maintain. And then it's also very durable. So the vertical wells in the ground, or the well drilling, typically can last for 50 to 100 years before you might have to replace the piping and the grout in the hole. And the warranty on the material and most of the machines is 20 to 25 years. So it lasts, 1.5 to 2 times longer than a typical furnace does in terms of the durability of the equipment. Another big benefit here is that no fossil fuel supply chain. So you don't need natural gas to be drilled for in some far off place. You don't need oil to be drilled for in some far off place to heat your house. You basically are using the heat that's directly underneath your grounds to heat and cool your space, and you don't need any of these extra fuel supply chains anymore. So you're cutting out, not just benefiting your own home, but you're also having a social benefit upstream by reducing the demand on all of these supply chains that create the fuels in the first place. And the ground source heat pump, I mentioned 55 to 65 degree temperature below the ground. The reason that's important is because you can install this virtually anywhere in the world or in any country and still save money and save energy. Because it's so readily accessible and because all you need is land, it's a really viable solution for pretty much any space heating and cooling need that you might have. And then I also mentioned that it's 5 times more efficient. So when you combine this with the efficiency plus the emission reduction, you're getting to about 87% to 90% less carbon emissions per unit of electricity consumed for a ground source heat pump. And when you combine that with a solar system or purchasing 100% clean electric, then you're basically getting down to 0 as a carbon footprint or an environmental impact. So combining these systems in different ways and doing some unique methods to power them with renewable energy can get you down to nearly no environmental impact whatsoever. So this chart here just kind of shows you what geothermal does versus natural gas. And then there's a summary here as well. Any questions about this? All right. And net benefit, I forgot to mention this, but you'll be saving money on your utilities by somewhere in the order of 30 to 60%, depending upon where you are and how much heating or cooling burden you have. Specifically in North Jersey, the burden for heating is more than the air conditioning burden. So you're benefiting a lot from using a ground source heat pump. So I'll get into some of the types, and this goes back to the flexibility of design depending upon each situation. This can be used for residential or commercial applications, but you basically have 2 big categories, which is open loop ground source heat pumps and closed loop ground source heat pumps. In an open loop situation, you're basically drawing from a well or a groundwater aquifer of some kind and using that in an open means. So you're drawing from one section and then using it to heat or cool your home and then putting it back in the reservoir in another way. This can be used for a pond as well. And it's also called a direct water source heat pump. So you can see up here, the red dot, number 1 up here shows you some of the highlights there. And then closed loop is a system where basically the water in the pipes is completely enclosed in a loop that interfaces with your home or your commercial building. And there's a bunch of different ways to do this. First off is a vertical well where you drill down into the earth somewhere between 100 to 400 feet vertically. And then you run a loop inside of that well and fill this hole with grout to increase the thermal conductivity. So you can drill vertically, and essentially all you really need is a 20 feet square section of property. So a very, very small yard to drill 1 or 2 wells, depending upon how much heat you need. Additionally, you can do horizontal if you have the space. You can dig down and excavate and then lay the coil in the bottom of the trench and then fill it back. Or you can bury a coil system not bury it, but submerge it in a pond where the water temperature is pretty steady, well below the surface. So these are all different ways that you can basically attach the ground loop to the house in a closed loop fashion. So lots of unique opportunities here. At my house, I have 3 250-foot wells drilled with one continuous loop. So the total length of pipe is 1,500 feet of circulation, essentially. And the reason that the length of the tube is important is because it takes a little while for the heat to either go into the fluid or be extracted from the fluid and go back into the ground. So you need the fluid to sit there and resonate and basically dissipate the heat one way or the other. And that's why you need a little bit of residence time inside of the loop. As I mentioned, you can do ground source heat pump for commercial buildings as well. It's the same type of concept. You can drill any number of wells that's required to meet your heating or cooling demands. A lot of good use cases is for a parking lot where otherwise the space is not used. And if it's new construction, you can build these ground source loops as you're building the parking lot before you even pave over. So basically the ground loop can be attached to your central heating or air conditioner handlers. And then you can do the exact same thing as a typical heating and air conditioning system. So this is a interesting community heating type of a model with ground source heat pumps. So you can see the network of ground source loops feeding into all of these community buildings. And more communities are looking at urban design and green building infrastructure to figure out how to do these and build concepts into the construction before they even start. It's much easier to do the drilling in a rough open space than it is necessarily to go back and retrofit something. Although you can retrofit, it's just a little bit easier to do it up front. And the cost of that infrastructure can be built into the sale price of the commercial building or the residential communities like this. So essentially you're taking advantage of unused space in a commercial building, or if you're a resident and you have a section of your yard that is on the north side of your property that doesn't get a lot of sun, it can't be used for a garden or anything like that. You know, you can use a piece of your property to fulfill that as well. And I'm just going to share some pictures with you about my experience. So in 2020, as I mentioned, we came out and we did the first portion of the project, which was drilling, which took about a week. And they drilled 3 250-foot wells. And they were sectioned in a triangle. So you can see this drill rig came up. It was just a truck with a drill on the back. And they just slowly, meticulously went down into the ground and then fed the pipe down into the ground and filled it with grout. So that took about a week of drilling, and it created one single underground loop. So there's no seams or any type of connections underground. It's all just one continuous pipe. So they feed it down, they loop it in and out of those 3 holes, and then they trenched it to the side of my house and then connected through the side of my house here. So that was the first part of the project. And then the second part was the installation, which is connecting all of the equipment on the inside. And my system has cooling, heating, and hot water. So you can see the before and after photos here of my basement. On the left-hand side in the red box is a natural gas furnace and a natural gas hot water heater. And then I also had a air handler or a condenser unit on the outside of my house and a air handler in my attic that basically moved the air conditioning. So the final result was in my basement, I have a water tank, a hot water tank, and then this small gray box here is the water furnace geothermal unit. These big black pipes here is the water loop, and the pumps are all the way on the left-hand side. So when my house needs heat, it connects with the baseboard hot water in my house and feeds heat in that way, but it also pumps water up to the air handler in my attic, hot water, and then the air handler will interface with the air and blow hot air through my house. So I get heated that way. And then in the summertime when it's cool, when it's hot, the air conditioning basically works in reverse, where they're going to take cold water from from the ground, pump it up to the air handler, and then blow cold air into the house to cool it off and extract all the hot air in reverse. But you can see that the natural gas furnace emission pipe is capped off here because essentially I don't use any natural gas anymore with the exception of my stove, my cooking stove. But that entire emissions was about 50,000 kilowatt hours of natural gas burned every year, about 2,000 therms. So a lot of emissions going out, and now you can see there's no emissions. There's no fuel being burned, and there's no emissions in the basement. But this is kind of pretty much how it works. So you're dealing with a lot of the same equipment. It's just that it all gets installed in your basement. Any questions on the install portion?
How's it working? You just had it for like 2 months, right? I mean, it's a big leap of faith to take all that stuff out and do that.
Well, it's working great.
Yeah.
You know, we're extremely comfortable in the wintertime. If we've had a couple cold snaps, and it's no problem. All you do is turn up the heat system on the water, and then it compensates for it. But it operates just like a normal furnace. You set the temperature, and then the system does the rest and keeps your air temperature at a steady state. So, you know, we keep our air temperature somewhere between 68 and 72 degrees. But basically, it's the same thermostat, and you just interface with it identically the same. Same for the air conditioning. But we have zero complaints so far.
So I know you're pretty much carbon neutral. I mean, you're done with your solar and everything. This kind of renewable energy on, like, you showed that commercial area. Is the cost coming down that it makes that something that would be practical to start talking about on a planning level, or?
Yeah, I mean, it's much the only real difference in cost is the ground loop. So the drilling that's required to bury whatever piping is necessary to create the thermal exchange. But the furnace and all the connections and all the equipment is pretty much the same as a normal natural gas furnace. So the advantage of getting this into a planning set is that all of that is built into the cost already, and it's much easier and cheaper to do you know, a excavation or a drilling before any foundations or any final prep work has been done on the site. You know, I kind of did it the hard way, where retrofitted a house, and this isn't the least expensive way, but it can be done. But I also want to encourage people to, you know, look at a solution like this, because specifically in the Northeast, you don't really have a viable solution to eliminate your fuel source if you are using natural gas heat. You can use an air source heat pump, but then essentially you're using more electric, and the coefficient of performance is around 300 to 350% or so. And then you need, in that case, you would need a larger solar system to offset the electric from the air source heat pump. So,
Yeah.
but in terms of viability, there are solutions on the table to potentially have the utility own basically the ground loops and subsidize that portion of the project, whether for commercial or residential. But figuring out how to have a community system that shares the burden is really sort of the sweet spot for this technology, and doing it.
Yeah, so that'll be to come, right? I mean,
yeah.
When JCP&L when people will start, when the utilities will start putting these things in, because it's worth their while.
Yep.
Okay, thanks.
Yep. And I also want to mention that, you know, this system will last twice as long as the natural gas furnace, roughly. So, you know, you're getting twice the useful life out of the machine as opposed to a natural gas furnace.
And you can use this with any type of heating system, whether it's a forced hot air or.
Yeah. Yeah. So if you have baseboard hot water and just a water boiler,
Mhm.
you can tie directly into the baseboard and just have it circulate the hot water that way.
Mhm.
I happen to have baseboard hot water heat and also air heat now. So I have a second option for my heating. And then cooling just operates with the normal air handler and the air conditioning. So it blows cold air through the vents in my house. But either system you can do it. And it's a really awesome technology because you can get very specific about your zones, and the temperature controls are very specific. So you can get pretty good conditioning in any portion of your house. So here's my references. So you can click on some of these references if you want more information, but I'm gathering information from Department of Energy, the Environmental Protection Agency, and a bunch of other resources. And if you want additional information, here's some other stuff which you can read through, including sustainablejersey.com and Parsippany Green Team, our Facebook page. But there's Wikipedia on here, EPA, Department of Energy, EnergyStar.gov is where you can look at different geothermal units. This is the International Ground Source Heat Pump Association and the Geothermal Heat Pump Consortium as well. So plenty of technology out there, plenty of resources, and really this is an elegant solution for solving the heating burden in our area, as well as other areas throughout the United States. And you can also solve the cooling aspect where you're basically getting your cold air from thermal air from the underneath the ground as opposed to running an air conditioning system.
Oh. Thank you.
Yep.
Thanks for sharing that. And just some of these resources, what you'll put on the Facebook page. We're getting a web page soon too.
Yeah.
In a few days. So, because there's just so much going on and so many people on the team with working with the municipality, and we want to have a place to land everything on a Facebook, not Facebook, a web page,
Yep.
so that the resources can be readily available.
Yep.
Hi, Danny, and that little cutie there. And Christine's here too, and Susan. Nice. So
I'm going to stop the recording and then we could just have a discussion. So
yeah.
Do you want me
Okay.
to stop? Can you, should I have to stop that or can you?